And the theme of the session is git-annex and special remotes, and it's a necessity that Joey is the first speaker in that session. As you heard, we asked this year all the presenters to give us a short bio, and Joey wrote, Joey is the author of git-annex, which is correct, but I still remember when I got in touch with the Debian project many years ago, I noticed in the man pages that one name came up, repeatedly, and for a while, not knowing exactly the mechanics of the project, I thought, well, this must be the guy behind it. And even today, you heard about Etsy Keeper and all the the other small and large things that he's written. So excited to have another talk by you.
Thanks, Michael. So I'm going to talk about, actually, I'm really happy to be right after Julia's talk because I'm kind of coming at this from a documentation or learning angle. If we look at the git-annex ecosystem, various people here will be using various of the things at the top, like Forgio or DataLad or OpenNeuro. And one thing that I kind of wonder about being in the middle here, git-annex with Git down below in the dependency chain, is how do users really, users who are using things up here at the top, how do they think about what's in the middle and what's at the bottom? Do they understand it at all? And if you look at the documentation of Git and of git-annex, well, Git has about a novel's worth of documentation just of the Git commands. There's like 100 Git commands. You can learn them all. That's going to take a while. Git-annex has, 66 commands and maybe a novella or so of documentation of the commands, and then there's all the other documentation too. This is just the man pages themselves. Not a good way to learn about these things if you're clicking around on a web interface and trying to figure out what is this how is it distributed at all? It looks just like GitHub. So when I learned Git, I think I may have learned it from this, this blog post, Git for Computer Scientists, or something very like it. And this thing just says, here's Git. It's a DAG of objects. They are blobs, they're trees, they're commits, there are some references. You can kind of figure out all the rest on your own. Just think about how these things would fit together and how you would manipulate them and use them, right? That's all you need. And I was like, perfect, that's all I need, and that's all I needed. I still think about Git this way, I don't need to remember how do I use git re or something. I just think about, well, I probably want to move this around like that. Okay, there's a command probably out there to do it. So I kind of wanted to do something a little bit similar today, at least in the first part of this talk, and just pick out a few of the main core pieces of git-annex. And I'm not going to explain how git-annex works today or anything like that. I'm just going to show a few of the core pieces of git-annex, the core data types, and maybe you can figure out how to use it from that, or maybe get at least a base conception of it. So to start with, we have annex objects, and there's some kind of a file that you want to version control. They're generally a large file, and you don't want to store them in your Git repository. That's why you're using git-annex in the first place. You don't want to be cloning a repository and getting a terabyte of data dumped into your laptop where you don't have a terabyte of data free, for example. So all we do is we hash some kind of a large file. We come up with a checksum-based identifier, and now we have a key value store, right? And here it's using a SHA-1, but it can use different hashes. There's a size field there, and then we have a hash. It's pretty simple. Second thing is pointers. Very basic concept. Pointers are great, obviously. And what we do with pointers here is we check in a pointer into the Git repository that points to one of these objects. And the best way to do it is using symlinks, if you have a Unix system that supports symlinks, because symlinks are a pointer. They're a pointer on the file system. Here we have a file foo, and it's pointing to some directory with the object identifier at the end. Okay, so we have a pointer to that object. Now, the best thing about symlinks is they can break, and normally that seems like a bad thing. You have a broken symlink to a file, so you have a problem. But here, you have a solution, which is that I don't have this on my disk, but I still have file foo, and I can think about file foo, and I can even get the content of file foo if I want it. So some people can't use symlinks. There's complications, but we have pointers checked into Git to the objects which aren't checked into Git and which git-annex manages. So the third piece is remotes, and if you know about Git, you know about remotes already. A remote is another kind of pointer, but here it's a connection between one repository and another one. In git-annex, we can have Git repositories, or we can have special remotes, which is like something that isn't a Git repository that's specific to some kind of a data storage system or something like that. Now, the key thing in git-annex is that every repository has a unique identifier. We use a UUID to identify it, and the reason we need to do that is because each git-annex repository stores some set of the annex objects, not everything. And so if you want a copy of a particular object, you need to know where that is so that you can go get it if you want a copy of it. And so git-annex assigns a UUID to everything. So here, if you have your repository up here at the top and an origin remote down here, they each have a UUID, okay? And then the fourth piece of git-annex, and maybe the piece that might seem unnecessary, but turns out to be really useful, is that git-annex maintains its own branch called the git-annex branch, which is checked into Git, and it contains metadata about the repository. And the main thing, and the reason this came into being, is the git-annex branch tracks the locations of each object stored in the repository. So here, for example, this isn't how it actually looks, but this is what it's saying in the git-annex branch is, this object is in this repository, okay? And the most important thing about the git-annex branch is that if you have two of them and you want to merge them together, you can always do that. The merge always succeeds. It's always going to be eventually consistent. And it's basically a CRDT, to use a computer science term. So, for example, if we run the command git-annex get, right, and we have this pointer file in our repository, file foo, which is pointing to some object, what happens? Well, we also have the git-annex branch saying where foo is located, and we have this topology of remotes, right? Well, git-annex says, oh, okay, I can get it from down here, so it goes to this remote, it copies it into the local repository, populating where that symlink points with the file. Now you have the file in the repository, and also updated the git-annex branch to say, oh, it's also stored over here. And this way, if you push that git-annex branch to somebody else, they know then that you have a copy of the file. And they could get it from you if they have you as a remote, for example. Does that make sense? Okay, any questions about this? Because that's really all the core concepts that I'm gonna use in this talk and that I think you would need to know, to come at this from the computer science perspective, if that's what this is. Okay, if there aren't any questions, I can go on, and I thought I might use the remainder of my time, however much I end up having, to talk about some git-annex features that I've implemented since we were here last. And last time we were here, I stood up on the stage and said, well, I don't think I can really come up with many good more features. It seems kind of maybe done. And then I came up with a few of which are here. So I could talk about any of these, and if anybody really wants to see one and we're getting near the end, please shout it out. But I'll just start, I think, with the compute special remote, since it's kind of germane to things that people are talking about here, like datalad run, for example. So the compute special remote, you can think of it as a repository, but it doesn't store a copy of the object. It remembers how to compute an object from some other inputs, which could be other objects, or maybe some other parameters that you need to pass to something. And git-annex doesn't know how to do a bunch of different computations. All it knows how to do is run a program, git-annex compute, with whatever the name you add to it. And you have to install this yourself. This isn't something git-annex provides to you. So if we start by initializing a compute remote, we're going to create a remote named foo. and it's going to use this program git-annex compute image convert, which is something that can convert, say, a JPEG to a GIF or whatever kind of images like that conversion, something like that. If we run this command, all git-annex does is it says, okay, I'm going to add this remote called image convert, and I'm just going to remember that it runs this image convert command. That's all I need to do. Okay, great, we've got a compute remote, done. So let's say we want to use it. The way we use it is we have a command git-annex add computed, and we can say, I've got this foo.jpg already. I'd like to have a GIF produced from this JPEG, right? I'll run a command like this, and what this will do is git-annex will say, okay, I'm going to run that git-annex compute image convert program, and I will feed in the input, the object there for foo.jpg. I'll get some kind of a result. I'll hash that, create my new object, check that pointer into the repository, populate the object with it since I've got it now, and I'm going to remember everything that I need to do it again, right? And you can read this. I'm not going to try to go through it, but if you look at what's there, it's enough information to repeat this process. So if you say, dropped this content from the repository, the foo.gif object, it would say, okay, sure, I can recompute it, so I'll compute it again later. Let me say also about reproducibility. Right now, as shown, if it doesn't have this SHA-1 and you try to get it again from the compute remote, it's just going to fail. It's going to say, oh, looks like you got the wrong content. Something's broken. It's not there. Too bad. But you can also say, hey, it's an unreproducible computation. And what happens is we just use a different kind of an object. Rather than a SHA-1 hash or something, we use an internal object type that git-annex has that allows multiple versions of a file to all be treated as one thing. So that is supported if you're curious. So that's how the compute special remote basically works. And I thought I would kind of use that to move on to this proxy thing. And I'm sorry if this is a lot of concepts, but it's just all the new stuff that I've come up with. Proxies is an idea where if you have a repository here that has a remote bar, right? And bar has, say, it's the one that we had earlier. It's got this image convert remote. So what if you're up here and this is on a different computer, bar and the image convert program and all that is over here, but you're over here and you want to get the file out of this image convert remote, right? Well, you'd have to download the program, set up the remote, run the command on your local system. Maybe you don't want to do that. Maybe it's too expensive or too hard, or you don't trust the command. So instead, you can delegate it. You can say, I've got access to this bar remote, and the bar remote can say, I'm willing to proxy for the image for this remote with this identifier here, this UID, and it's called image convert to me. And what that does is it creates basically it magics up out of thin air this bar image convert remote, which you can almost think of, if you think about UUCP way back in the day, bang paths, or Usenet way back in the day. You've kind of got a bang path here, bar image convert. It's saying, go here, then go here. And how this works is, if you say, get me a file from bar image convert, it goes, it talks to bar, it says, hey, could you get me the file from image convert, and then it just relays it back out through the proxy. Does that make sense? Yeah, it seems pretty simple. I think it can do a lot of interesting things. It doesn't have to be a compute remote here. You could have a S3 bucket, which you need credentials to access, and you don't want to share the credentials with everybody, right? So you just slap up a proxy and everything goes through the proxy. You pay the network bandwidth penalty, but so what? You don't have to share credentials and it's easy. There's lots of ways you can use this, and they can go just as deep as you would like, actually. So, another fun feature, another kind of special remote. This one, the idea came up and I implemented it in, I think, under a day, which was really nice because the previous thing took like 2 months. Is the idea of a mask special remote. So the idea here is git-annex can encrypt files stored on special remotes, but maybe you have a special remote that is not encrypted because it's something public, but maybe it has some files in it that you only want to share with a certain subset of people, say because they're patient data, if you're doing, some kind of medical research, or I don't know, you come up with the idea. So what you can do is you can have one remote that adds a layer of encryption to another remote, and you end up mixing these annex objects. You have encrypted ones, which are the one down here with the GPG HMAC thing. Ignore, that doesn't really matter. It's just an encrypted object. The one up there is, of course, an unencrypted object, and you can store them both in the same remote, but keep them straight. Keep, not get all things mixed up. And the way this works, I'll wait for, okay. The way this works is, cool. The way this works is when you initialize this remote, you say, I would like a mask remote, and it's going to mask the remote named foo. I have this remote foo, that's the unencrypted one. I'm gonna mask it, and I'm gonna encrypt it with, say, I'll let these people, these GPG keys have access to it, for example. You could use any kind of encryption that git-annex supports. And what it does is it just stores on the git-annex branch that this remote masks this one. That's all it really needs to do, and it creates the remote. And when you use it, all that happens is if you're getting a file and it's on the foo encrypted remote, all that git-annex does is it downloads the encrypted file from the foo remote, decrypts it, and then there you got it. So it's basically a transparent encryption layer. Very simple, really. Okay, I think I have just enough time to get to the last thing I wanted to talk about, which is the kind of behemoth of it all, which is cluster support. So this builds on the proxying, actually. And what this does is it lets you have a collection of remotes, like down here we have 3 nodes, and they are located behind another repository, which is the bar remote here, the one in the middle. And the whole cluster, to the end user, to you up here who have the bar remote, it looks like one repository. If you say, get a file from bar, well, what is it? Okay, I don't have an example. If you say get a file from bar, it just goes to bar and it says, give me the file. But bar is like, oh, I've got that on these 2 nodes here, 9C and 00. Okay, it's on 2 and 3, so I'll get it from 3 because 3 isn't very busy right now, or something like that, right? So, and then it just provides it to the user. If you say send the file into this cluster, then, well, it could just store on every node. It could store it on one node. It's up to you. You can configure which nodes want which files. git-annex has a mechanism for that, which I'm not going to go into here because it's not really a core feature or a core data type. But this lets you have actually arbitrarily complicated topologies of clusters. You can have a cluster with multiple parts that are distributed geographically, for example. You could have, multiple of these remotes, but they're all treated as one cluster. You can have a complicated structure that goes down as deep as you need to, and so on. So I think this is pretty neat, and I would love to hear about somebody actually using it. And I should say this is kind of inspired by the Garage project, which is a distributed S3 clone, which is also geographically distributed. So that's really everything I wanted to talk about today. There are, of course, other features, but maybe we'll save them for another time. I hope that this is kind of giving you another way to think about how git-annex works. It makes it kind of just seem a little bit simpler under the hood than all the, there's a lot of complexity going on here, but it's really fairly simple things. All we need for clustering is to know which nodes are in the cluster. And one thing that happens that I'll mention is, if you look here, it says that this SHA-1 object is in these 2 nodes, but it doesn't say it's in the cluster. If you say git-annex get, it has to know, oh, I know that a cluster exists. I know that it's in one of the nodes of the cluster. Therefore, it must be in the cluster. And it just does that implicitly, so it doesn't have to, repeat itself. Which is probably the main complication of this, is that we now have a concept of a kind of a higher order object location. But anyway, it all just happens to work fairly well, luckily. Okay, if there are any quick comments or questions, I'll take them. Otherwise, we can talk about it later.